So today we'll discuss the 12th session on relative velocity. This will be in continuation of the 11th session. In the 11th session on relative velocity, it was discussed in theoretically why displacement of a moving point P in a given time interval depends on the frame of reference. So in the 12th video today, we will take up some more theoretical examples to demonstrate this concept. Namely that displacement of a point as seen from two different frames in a given time interval is not the same. This is what we are going to discuss today. So this should be read in continuation with the 11th session and the 7th session. So 7th session was on the detailed theory of reference frame, and 11th session was totally dependent on the 7th session. And 12th session is in continuation of the 11th session, in which we will discuss why displacement of a moving point in a given time interval depends on the frame of reference. On this we'll take some theoretical examples. Alright. So let's take the first example in this way. Namely like this. Suppose this is the ground frame, okay? G is the ground frame. G denotes the ground frame. And this is the wedge, a triangular block taken to be a rigid body. So this is wedge, which will be denoted by W, and G for ground. This is the ground frame, okay? Suppose that P is a moving point. This is the actual wedge. This is the material, that is the material body, wedge, taken to be a rigid body. And W means the wedge frame of the wedge. Suppose P is a moving point which was initially at the highest point of the wedge, P. Suppose the point P was at the highest point of the wedge at say 7 am. 7 am, okay? So at 7 am, point P is at the highest point of the wedge. Suppose it occupies the G1 location of ground frame and W1 location of the wedge frame at 7 am. Fine. Now what happens? This point starts to slide down the wedge, and due to some reason, perhaps some additional forces are acting on the wedge begins to move rightward with respect to ground. Okay. So this arrow indicates that wedge moves rightward with respect to ground. And point P at 7 am occupies the ground frame, location G1 of ground frame and location W1 of the wedge frame. Alright. Now what happens? That this wedge begins to move rightward with respect to ground. And point P starts to slide down the wedge incline. Okay. So now what happens that after some time, say 5 minutes later, the wedge comes here, somewhere here. Okay. So now we are trying to discuss the displacement of point in a given time interval in two different frames, ground frame and wedge frame. Okay. So we are assuming that wedge is moving rightward with respect to ground. Okay. So we are drawing the diagram from ground frame. Alright. So what happens? 5 minutes later, wedge moves ahead. So this is the wedge. This wedge comes here, say at 7:05 am, 5 minutes later. And point P comes here. Point P comes here at the base of the wedge at 7:05 am. At 7:05 am, point P occupies the location G2 of ground frame and location W2 of the wedge frame. Okay. This is the situation at 7:05 am. And this is the situation at 7 am. As mentioned just now, I have drawn the diagram with respect to from ground. Okay. So now our aim is now to find the displacement of point P in the time interval 7 am to 7:05 am with respect to ground and with respect to wedge. This displacement we have to find. First of all, what we do, we find the displacement of P with respect to ground frame in this time interval 7 am to 7:05 am. Okay. For this we have to consider which locations of ground frame point P occupies at 7 am and 7:05 am? If we have to determine the displacement of P with respect to ground frame. So at 7 am point P occupies location G1 of ground frame, which is the initial location of point P in ground frame at G1. And at 7:05 am point P occupies location G2 of ground frame, which is the final location of point P in ground frame at 7:05 am. So in ground frame, we'll say like this. G1 is the initial location of P and G2 is the final location of P. So now we are finding the displacement in the time interval 7 am to 7:05 am. As mentioned in the 11th video and in the previous videos also, displacement of P in 7 am to 7:05 am will be actually be calculated at 7:05 am. So we have to see at 7:05 am where G2 and G1 are situated. At 7:05 am G2 is situated here. Now we have to know at 7:05 am where G1 will appear to be. So now, as I mentioned just now, diagram is being drawn from ground frame. With respect to ground, ground is at rest. And G1 is rigidly connected to ground because it's a real or imaginary location of ground frame. It is rigidly connected to G1, ground frame G. So if G doesn't move, then G1 also doesn't move. This means at 7:05 am, G1 will appear to be at same location as it was at 7 am. At 7 am, G1 is at this location. So at 7:05 am also, G1 will be at the same location. And at 7:05 am, G2 is at this location. So displacement of P with respect to ground in 7 am to 7:05 am is the vector from initial location G1 to final location G2. So this is the displacement of point P in ground frame, dPg. This arrow from P1 to P2, from this G1 to G2, sorry, not P1 to P2, G1 to G2. So this is the displacement of P with respect to ground frame in the interval 7 am to 7:05 am. This is the displacement of point P with respect to ground frame in the interval 7 am to 7:05 am. dPg, initial location G1 to final location G2 as seen at time t2. Fine. Now our aim is to find the displacement of P with respect to wedge frame in the time interval 7 am to 7:05 am. For this we have to consider which locations of wedge frame point P occupies at these two time instants. At initial instant 7 am, point P occupies location W1 of wedge frame, and at 7:05 am it will occupies location W2 of wedge frame. Okay. So now we have to find the displacement of P with respect to wedge frame in 7 am to 7:05 am. So as mentioned previously, the displacement will be actually be calculated at 7:05 am. So at 7:05 am we have to see where W2 and W1 are situated. At 7:05 am W2 is at this location. Now we have to see at 7:05 am where W1 is located. We have to see where W1 is located at 7:05 am. Now the diagram is being drawn from ground. With respect to ground, wedge is moving rightward. If wedge and W1 is rigidly connected to the wedge. So if wedge moves rightward, W1 also moves rightward along with it. So at 7:05 am, W1 was initially here at 7 am. So at 7:05 am, W1 will appear to be at this location. And at 7:05 am, W2 is here. So displacement of P with respect to wedge in 7 am to 7:05 am will be a vector from W1 to W2, this one. So this is the displacement of P with respect to wedge in the time interval 7 am to 7:05 am, dPW. D means displacement, P for point and comma, W for wedge frame. So this is the displacement of P with respect to wedge frame in 7 am to 7:05 am from here to here. And this is the displacement of P with respect to ground frame from this location to this location, dPg. So these two displacements, as you can see, these two arrows are not the same. So displacement of P with respect to ground dPg in the interval 7 am to 7:05 am is not the same as displacement of P with respect to wedge in the interval 7 am to 7:05 am. These two displacements are not the same. Again, why they are not the same? Because at 7:05 am, final location of P in ground frame and wedge frame G2 and W2, they are coincident. But at 7:05 am, initial location of point P in ground frame and wedge frame G1 and W1, G1 here, W1 here, they are non-coincident. And displacement is always from initial location to final location. So displacement of P in these two frames are not the same. Alright, clear? Fine. Okay, so in this case, whatever we explained, we assume that we have drawn the diagram from ground frame. Diagram was drawn from ground frame. Diagram was drawn from ground frame. Diagram we drew from the ground frame. So these two displacements are not the same. Fine. Okay. Now we'll take another example. Okay. I'll just rub it, okay? I'll rub it, huh? Okay. It's the same problem we'll now discuss. Suppose we draw the diagram from wedge frame. The example we took just now, we drew the diagram from ground frame. Now suppose we solve the same problem, but we draw the diagram from wedge frame. The same problem we'll discuss, but diagram will be drawn from the wedge frame. Diagram drawn from wedge frame. Diagram drawn from wedge frame. Okay. So this is the ground frame. This is the wedge, W for wedge. Particle was initially at the highest point of the wedge, point P at 7 am. At 7 am, point P occupies location G1 of ground frame and location W1 of the wedge frame. This is the state situation at 7 am. P occupies location G1 of ground frame and location W1 of the wedge frame. Alright. P occupies location G1 of the ground frame and location W1 of wedge frame at 7 am. Now again in this case we'll draw the diagram from wedge frame. Okay. Now suppose the point moves downward and at 7:05 am it comes here. So we draw the diagram from wedge frame. As seen from wedge frame, wedge is at rest. So at 7:05 am also wedge will be at same location as it was at 7 am. So at 7:05 am also wedge will be at the same location. So at 7:05 am point P is coming here. Okay, fine. So this is the point P at 7:05 am. It occupies location G2 of ground frame and location W2 of wedge frame. It occupies location G2 of wedge ground frame and location W2 of wedge frame at 7:05 am. Now again our aim is to find the displacement of P in this time interval as seen from wedge frame and as seen from ground frame. So first we'll find the displacement of P as seen from wedge frame in 7 am to 7:05 am. So for that we have to consider which locations of wedge frame point P occupies at these two time instants. The initial location of wedge frame is W1 and final location of P in wedge frame at 7:05 am is W2. So W1 is the initial location of P in wedge frame, and P2 is the final, W2 is the final location of P in wedge frame. So W1 is the initial location of P in wedge frame, and W2 is the final location of P in wedge frame. Now displacement we have to find in the interval 7 am to 7:05 am. As mentioned previously, displacement will be calculated at 7:05 am. At 7:05 am we have to see where W2 and W1 are situated. At 7:05 am W2 is here. Now we have to see at 7:05 am where W1 will appear to be. As mentioned just now, diagram is drawn from wedge frame. As seen from wedge frame, wedge is at rest and W1 is rigidly connected to the wedge. So if wedge W doesn't move, then W1 also doesn't move because it is rigidly connected to wedge frame. So at 7:05 am also W1 will appear to be at same location where it appeared at 7 am. At 7 am W1 was here, so at 7:05 am also W1 will be at same location. And at 7:05 am W2 is here. So this is the displacement of P with respect to wedge frame. This is the displacement of P with respect to wedge frame in the interval 7 am to 7:05 am. Okay, fine. Now we have to find the displacement of P with respect to ground in this time interval 7 am to 7:05 am. For that we have to see which locations of ground frame point P occupies at these two time instants. So at 7 am point P occupies location G1 of ground frame, and 7:05 am it occupies location G2 of ground frame. Now we have to find the displacement of P with respect to ground frame in 7 am to 7:05 am. Actual calculation will be carried out at 7:05 am. So we have to see at 7:05 am where G1 and G2 are situated. At 7:05 am G2 is situated here. Now we have to see at 7:05 am where G1 will appear to be. The diagram is drawn from wedge frame. Now with respect to ground, wedge is moving rightward. With respect to ground, wedge is moving rightward. So as seen from wedge, ground will appear to move leftward. If ground, now G1 is rigidly connected to ground. So I'll repeat it. With respect to ground, wedge is moving rightward. Therefore, with respect to wedge, ground will appear to go backward. Now, ground will appear to go leftward, and G1 is rigidly connected to ground. So if ground G moves leftward, G1 also moves along with ground towards leftward direction. So at 7:05 am, G1 will appear to be somewhere here. Because with respect to wedge, ground is moving leftward and G1 is rigidly connected to ground. So if G moves leftward, G1 also moves along with it leftward. So at 7:05 am, G1 will appear to be at this location. And at 7:05 am, G2 will appear to be at this location. So displacement of P with respect to ground in the interval 7 am to 7:05 am will be from initial location G1 to final location G2, that is DPG. This can be seen that this DPG is same as when we found DPG by drawing diagram from ground. In this case we have drawn diagram from wedge, but again DPW and previous DPW they are same, and DPG and previous DPG they are also both the same. Fine. So one example I have discussed. I shall take up one more example. Okay. So this I am rubbing it. Fine. So now we take another example. Fine. River problem. We take a case of river problem. So I am repeatedly telling that without the basic knowledge of the basic concept of the reference frame, this problem cannot be understood theoretically. So 7th video was extremely important. It should definitely be discussed, seen, and then 11th session and 12th session they should be observed. Okay. So river problem. So now what happens here? What happens is this. This is the top view of the river. This is the river, denoted by R. top view. This indicates the river flow velocity is eastward with respect to ground. This is the south bank of the river. This is the south bank of the river. This is the south bank. This is the south bank. This is the north bank of the river. This is the north bank of the river. This is the river itself. Again here G means ground frame. G meaning ground frame. R meaning river frame. S is a swimmer. S means swimmer. Suppose the swimmer is at somewhere on the south bank at 9 a.m. 9 a.m. in the morning, the swimmer S is somewhere at the point on the south bank. Now what happens? This swimmer starts to swim across the river. Fine. At 9:30 a.m., swimmer comes here, somewhere on the north bank, just opposite to the starting point on the south bank. The swimmer is this location. Swimmer at 9:30 a.m. We are assuming that the swimmer takes half an hour to swim across the river. So at 9 a.m., swimmer S occupies location G1 of ground frame and location R1 of river frame. At 9 a.m., swimmer S occupies location G1 of ground frame and location R1 of the river frame. Okay. And at 9:30 a.m., swimmer is coming here. At 9:30 a.m., swimmer occupies location G2 of ground frame and location R2 of the river frame. This is the situation at 9:30 a.m. And this arrow indicates that the river is flowing rightward, ground with respect to ground. So now our aim is again to determine the displacement of swimmer with respect to river and with respect to ground in this time interval, 9 a.m. to 9:30 a.m. So this time we are to show the displacements on the diagram, we are drawing the diagram from the ground. Diagram is being drawn from ground. Diagram will draw from the ground. Okay. Diagram will be drawn from where? Ground. So now, suppose you want to find the displacement of swimmer with respect to ground in 9 a.m. to 9:30 a.m. For that we have to consider which locations of ground frame swimmer occupies at these two locations. So initial location of swimmer in ground frame is G1, that is the initial location of swimmer in ground frame. And at 9:30 a.m. swimmer occupies location G2 of ground, that is the final location of swimmer in ground frame. Now to find the displacement in 9 a.m. to 9:30 a.m., actual displacement will be calculated at 9:30 a.m. So we have to see at 9:30 a.m. where G2 and G1 will appear to be. At 9:30 a.m. G2 is here. Now we have to see at 9:30 a.m. where G1 will appear to be. Now we are drawing the diagram from ground. As seen from ground, ground is at rest and G1 is rigidly connected to ground. So if ground doesn't move, then G1 also doesn't move. So at 9:30 a.m. G1 will appear to be at same location as it was at 9 a.m. At 9 a.m. G1 was here. So at 9:30 a.m. also G1 is here itself. And at 9:30 a.m. G2 is here. So displacement of swimmer with respect to ground in 9 a.m. to 9:30 a.m. is displacement from initial location G1 to final location G2 at seen at 9:30 a.m. So this is DSG. DSG meaning displacement of swimmer with respect to ground in the interval 9 a.m. to 9:30 a.m. This is the displacement of swimmer with respect to ground in the interval 9 a.m. to 9:30 a.m. Now we have to know the displacement of swimmer with respect to river in 9 a.m. to 9:30 a.m. For that we have to see which locations of river frame swimmer occupies at these two instants. So initial location of swimmer in river frame at 9 a.m. was R1 and final location of swimmer in river frame at 9:30 a.m. is R2. So now we have to see at 9:30 a.m. where R2 and R1 will appear to be. Now at 9:30 a.m. R2 appears to be at this location. So now we have to see at 9:30 a.m. where R1 will appear to be. Now we are drawing the diagram from ground. As seen from ground, river flows towards east and R1 is rigidly connected to river. So if river moves rightward along eastward direction, R1 will also move along with the river towards eastward direction. So at 9:30 a.m. R1 will appear to be at here at 9:30 a.m. at 9:30 a.m. R1 will appear to be at this location, somewhere here. And at 9:30 a.m. R2 will appear to be at this location. So displacement of swimmer with respect to river in 9 a.m. to 9:30 a.m. will be displacement from initial location R1 to final location R2, and that is the displacement of swimmer with respect to river, that is DSR. Fine. So displacement of swimmer with respect to river in 9 a.m. to 9:30 a.m. will be from this point to this point. Again, it is seen from this diagram that DSR and DSG, they are not the same. They have a different direction and they have a different magnitude. So these two displacements are not the same. They are unequal. Again, why are they unequal? They are unequal because at 9:30 a.m. final locations of swimmer in ground frame and river frame G2 and R2, they are coincident. Whereas at 9:30 a.m. initial location of swimmer in ground frame and river frame G1 and R1, they are non-coincident. And displacement is from initial location to final location. So displacement in ground frame is from G1 to G2 and displacement in river is from R1 to R2. So that's why displacement of swimmer in these two frames are not the same. Because final location of swimmer in both the frames is coincident and initial location of swimmer in both the frames is non-coincident. So displacement of the swimmer in these two frames in this time interval is not the same. Fine. In this case, we drew the diagram from ground. Now we will discuss the same problem by drawing the diagram from river. I just rub it, okay? We discuss the same problem, but this time we will draw the diagram not from ground but from river. So diagram drawn from same problem. Okay. In this case also same displacement will get as we obtained by drawing the diagram from ground. So this is the top view. This arrow indicates the flow of river with respect to ground. This is the south bank, this is the north bank. Swimmer is somewhere on the south bank. Swimmer is somewhere on the south bank. Swimmer is somewhere on the south bank at 9 a.m. At 9 a.m. swimmer occupies location G1 of ground frame and location R1 of the river frame. This is the situation at 9 a.m. At 9 a.m. swimmer occupies location G1 of ground frame and location R1 of river frame. These two locations coincide at 9 a.m. Now we have to find the displacement of swimmer with respect to river and with respect to ground. When we drew the diagram from ground just before this, in that you saw that displacement of swimmer with respect to river was something like this, something like this. See now, if we show the displacement from river also, displacement of swimmer with respect to river will remain the same, irrespective of whether we draw the diagram from ground or we draw the diagram from river. Is it clear? When we draw in the previous, just before rubbing it, just before this, the previous on previous board, we assume that the swimmer in displacement of swimmer in ground frame was in this one, and we found DSR. So we have to know at least, irrespective of whether we draw the diagram from river or we draw the diagram from ground, we have to know one of the displacements, DSG and DSR. We should know at least one of them. Then we can find other. So here also, when we draw the diagram from river, then we should know at least DSG or we should know at least DSR. One of them should be known. Then only we can calculate the other. So suppose we assume that we know DSR. So DSR has to be same as that in the previous, just before previous subpart of this question. So this means at 9:30 a.m. swimmer should be somewhere here. 9:30 a.m. swimmer should be somewhere here. So this is the swimmer at 9:30 am. It occupies location G2 of ground frame and location R2 of river frame. This is the situation at 9:30 am. So at 9:30 am, swimmer occupies location G2 of ground frame and location R2 of river frame. This is the situation at 9:30 am. Okay. And this is the situation at 9 am. Now we have to show the displacement of swimmer with respect to river and with respect to ground. Suppose we show the displacement of swimmer with respect to river. For that we have to consider which locations of river frame swimmer occupies at these two instants. So initial location of swimmer in river frame is R1, 9 am. And final location of swimmer in river frame is R2, 9:30 am R2. Now displacement will be calculated at 9:30 am. So we have to see at 9:30 am where R2 and R1 will appear to be located. Now we are drawing the diagram from river. With respect to river, river is at rest. And R1 and R2 are rigidly connected to the river. So I'll just repeat it once again. We are finding the displacement of swimmer with respect to river, 9 am to 9:30 am. We have to see which locations of river frame swimmer occupies at these two instants. So these two locations are R1 and R2. As stated just now, displacement will be calculated at 9:30 am. So we have to see at 9:30 am where R2 and R1 will appear to be situated. At 9:30 am, R2 is here. Now we have to see at 9:30 am where R1 will appear to be. Now diagram is being drawn from river. With respect to river, river is at rest. And R1 is rigidly connected to river. So with respect to river, river is at rest and R1 is rigidly connected to river. And R1 also doesn't move if you draw the diagram from river. So at 9:30 am, R1 will appear to be at same location as it appeared to be at 9 am. So at 9:30 am, R1 is here and 9:30 am, R2 is here. So displacement of swimmer with respect to river is this DSR. The same DSR as we obtained in the previous part of this question. See, I'm repeating this. When you draw the diagram from ground, then we assume that displacement of swimmer with respect to ground was in this direction. Then we found DSR. At least we should know one of them. We should know DSR, we should know DSG, at least one of them. So in this we assume that we know DSR. Okay. In previous, when you drew the diagram from ground, we assume that we know DSG. Here we are assuming that we know DSR. So now what we have to do, we have to find the swimmer displacement of swimmer with respect to ground frame in 9 am to 9:30 am. For that we have to see which locations of ground frame swimmer occupies at these two instants. These two locations of ground frames are G2 and G1. Okay. Now displacement of swimmer with respect to ground in 9 am to 9:30 am will actually be calculated at 9:30 am. So we have to see at 9:30 am where G1 and G2 appear to be. At 9:30 am, G2 is here. Now we have to know at 9:30 am where G1 will appear to be. Now we are drawing the diagram from river. With respect to ground, river flows towards east. So with respect to river, ground will move towards left. And G1 is rigidly connected to ground. So as ground moves towards left, G1 also moves towards left. So at 9:30 am, G1 will appear to be at here. G1 will appear to be at here at 9:30 am. At 9:30 am, G1 will appear to be at this location. And at 9:30 am, G2 will appear to be at this location. So displacement of swimmer with respect to ground will be this DSG. This DSG is same as DSG which we obtained in the previous part of the question. Fine. So again we see that these DSR and DSG are not the same. And why they are not the same? Because final locations of swimmer in both the ground frame and river frame, G2, R2, they are coincident at 9:30 am. Whereas initial location of swimmer in ground frame and river frame, R1 and G1, they are non-coincident. Displacement is from initial location to final location. Initial location G1, R1 are non-coincident and final location G2, R2 are coincident. So displacement of swimmer in river frame and displacement of swimmer in ground frame, they are not the same. I hope it is fine, clear, alright. Okay, now I'll take one more example. Okay, so there's no end to it. Once you have understood the concept, you just have to apply it, that's all. It's a simple, not very tough, but you should know it. If you don't know it, then you can't explain this. See, what I'm telling you, I have seen from experience, my teaching experience, I have seen that people don't know this concept of reference frame. They don't understand why displacement depends on frame of reference. Yet they are able to solve all the complex problems. But when you go to and ask them, you show in the diagram why displacement depends on frame of reference, they cannot do it. They solve it, all right, you get the answer also. But when it comes to explaining on the diagram, people are not able to show it. But if you understand this case, then you will able to solve also, and you will able to explain also why displacement depends on the frame of observation. Fine. I'll take one more example, all right. I'll take up one more example, all right. Third example. Suppose this is the ground frame and this is a plank taken to be a rigid body. Plank. Plank. Denoted by W, say. Plank has been denoted by W. Alright. I should have denoted by P, but P means particle also, just to avoid confusion. I am denoting this plank by W. Alright. Plank is being denoted by W. Imagine that a P is a moving point which is initially at here. Alright. So P occupies location G1 of ground frame and location W1 of the plank frame, say at 4:30 p.m. 4:30 in the evening. Point P is here. It occupies location G1 of ground frame and location W1 of the wedge frame. This is the situation at 4:30 p.m. Alright. At 4:30 p.m. point P occupies location G1 of ground frame and location W1 of the plank frame at 4:30 p.m. Alright. Now what happens that P begins to move down with respect to ground and plank moves rightward with respect to ground. Alright. So at say 5 minutes later, point P comes here. Achha, I'll just write it in this here. This just take away the space now. Okay. So this is the situation at 4:30 p.m. 4:30 p.m. Alright. See, and P comes here. P, this is the location of P, say at 4:32 p.m. 2 minutes later. At this point, it occupies location G2 of ground frame and location W2 of the plank frame. This is the situation at 4:32 p.m. Alright. This is the situation at 4:32 p.m. point P here. And this point P here, G1 W1 at 4:30 p.m. And this is G2 W2 at 4:32 p.m. So we are drawing the diagram from ground, and it is given that the plank moves rightward with respect to ground. This arrow means that plank moves rightward with respect to ground. Okay. So now, what we have to do, that we have to find the displacement of P in both the frames, ground frame and wedge frame, in the time interval 4:30 p.m. to 4:32 p.m. So first we find the displacement of P with respect to ground in this interval, and then with respect to wedge in this interval, plank in this interval. So if we want to know the displacement of P with respect to ground in this interval, we have to see which locations of ground frame point P occupies at these two instants. And these two locations are G1 and G2. G1 is the initial location of P in ground frame, and G2 is the final location of P in ground frame. So this displacement we have calculated in 4:30 p.m. to 4:32 p.m. So we have to find this actual calculation will be done at 4:32 p.m. So we have to see at 4:32 p.m. where G2 and G1 appear to be located. Now diagram is being drawn from ground. With respect to ground, ground is at rest. And with respect to ground, ground is at rest. Okay. I'll just repeat it. See, we are finding the displacement of P with respect to ground in 4:30 p.m. to 4:32 p.m. For that, we have to first see which locations of ground frame point P occupies at these two instants. These two locations are G1 and G2. G1 is the initial location, G2 is the final location. Now, actual calculation will be done at 4:32 p.m. So, we have to see at 4:32 p.m. where G2 and G1 will appear to be located. At 4:32 p.m. G2 is located somewhere here. Now, we have to see at 4:32 p.m. where G1 will appear to be located. Now, diagram is being drawn from ground. With respect to ground, ground is at rest, and G1 is rigidly connected to ground. So if ground doesn't move, then G1 also doesn't move. So at 4:32 p.m. G1 will appear to be at same location as it appeared to be at 4:30 p.m. At 4:30 p.m. G1 appears to be here. So at 4:32 p.m. also G1 appears to be at this location. And at 4:32 p.m. G2 appears to be located at this location. So displacement of P in ground frame will be this, dpg. dpg is the displacement of P with respect to ground frame in the interval 4:30 p.m. to 4:32 p.m. Now what we have to do, we have to find the displacement of P with respect to Planck frame in the interval 4:30 p.m. to 4:32 p.m. So for that we have to see which locations of Planck frame point occupies at these two instants. So these two locations are W1 and W2. W1 is the initial location of P and W2 is the final location of P. Now with displacement we are finding in interval 4:30 p.m. to 4:32 p.m. Then actual calculation will be done at 4:32 p.m. So we have to see at 4:32 p.m. where W1 and W2 will appear to be located. At 4:32 p.m. W2 appears to be located here. Now we have to see at 4:32 p.m. where W1 will appear to be located. Now diagram is being drawn from ground. With respect to ground, Planck moves rightward. So this is the Planck at 4:30 p.m. 4:30 p.m. So at 4:32 p.m. Planck will move some distance ahead. Okay, this is the Planck at 4:32 p.m. Planck is here shorter, space is less, so I've drawn a smaller Planck. Okay. So at 4:32 p.m. Planck will appear to be at this location, P. Planck will appear to be at this location at 4:32 p.m. Now P1 is rigidly connected, W1 is rigidly connected to the Planck. So Planck moves rightward, and W1 will also move accordingly with the Planck. So at 4:32 p.m. W1 will appear to be somewhere at this location at 4:32 p.m. And at 4:32 p.m. W2 is here. So displacement of Planck with respect to particle with respect to Planck in the interval 4:30 to 4:32 p.m. is this one, dpw. So you can see these two displacements are not the same. Why they are not the same? Because final location of P in both the frames, Planck frame and ground frame, G2 and W2, they coincide at 4:32 p.m. But at 4:32 p.m. initial location of P in ground frame and Planck frame, G1 and W1, they do not coincide. And displacement is from initial location to final location. So displacements of point P in both the frames are not the same. Not the same because final location of P in both the frames, G2, W2 coincide. And initial location of P in both the frames, G1, W1, at 4:32 p.m. they are non-coincident. So displacement is initial location to final location. Final location, same location. Initial locations are different locations. One displacement is this, one displacement is this. They are not the same. Fine. So one last point I would like to repeat. See, if you don't know the definition of reference frame, this exact definition which we have discussed in the 7th video, what problem is it going to cause? Tell me. Problem will be that if you don't know that W1 is connected to the Planck, then you will not know that at 4:32 p.m. W1 will be at this location, but you will erroneously say that W1 is here itself at 4:32 p.m. also. Is it clear? If you don't know this definition of reference frame, that W1 is rigidly connected to the Planck. So if Planck moves rightward, W1 also moves rightward. This if you don't know, then what will happen that 4:32 p.m. also you will say that W1 is at same location as it was at 4:30 p.m. Then what will happen? You will say that displacement of P in ground frame and Planck frame both are same. That's a mistake. Even though you have carried out all the calculation, but when it goes to explain the basic, you are again back to the same mistake. You will say that W1 will be at 4:32 p.m. also. W1 will be at same location as it appeared to be at 4:30 p.m. At 4:30 p.m. W1 is here. So you will say that 4:32 p.m. also W1 is at this location. So displacement of P in Planck frame will also be from here to here, same as in ground frame, which is wrong. So this definition of reference frame is extremely vital. That's why I am repeatedly telling you that again and again, that only when you understand the 7th video, contents of 7th video is fully understood, then only you should read this 11th and 12th session on relative velocity. But once you have understood the definition of reference frame, it is easy, there is no problem. But you must know it because you won't get this definition everywhere. In rarest few books you get this definition. So be very careful, that's what I am telling. Okay, so I hope this discussion is complete. You people have totally understood it, I hope so. So if you don't understand, go through it again. Just make a replay of it. Just watch this video, you go back again, you watch it again, it will be clear. It's not very difficult. But first you must know the definition of frame. That's what I'm telling you again. So the definition of reference frame is extremely crucial to understand the chapter on relative velocity. Okay. So this is all I have to say. Fine. So next session we'll carry out the exact calculations of relative velocity. Okay. So this is all. Okay. So now we close it. All right.